semesters, they're, they may be slightly different, but they're just as informative. They'll give you the information and the practice you need. So going back to where we were from last week, we're starting on page 24 in the book, doing the example 2.1. And you want to make sure that you open up a file in the editor window. There's always one there anyway, and it's usually a blank one, or hit the little plus button here to open up a new file. And you want to make a file like this because this is where you get your participation points in this class. So you make a file with your name and the date in example 2.1, and you're going to follow along typing things into this file as we go for your participation credit in this class. And that's worth what, I don't remember what it was, 20% of your grade or something like that. So make sure that you do that. And then we'll get started on this ideal gas law example here, where we started off by putting a pause function in here, which makes everything just kind of hold still while the user gets ready to run the program, and then they hit a key to make it run. Then we're going to go ahead and clear our workspace. We're going to clear the command window, and we're going to put P equals 100. That's our pressure. We have T equals 300. We're going to put a little comment there. That's our temperature in Kelvin, right? So that's in kelvins. And then we'll put our comment here for our volume in meters cubed. So we put that as meters cubed. I believe you can also, I'm trying to remember if you don't like that way of writing things, I believe, maybe I'm wrong. I thought they put a thing in here where you could put like something in the exponent, but maybe not. So anyway, we'll just put it as meters, little caret hat cubed. So the volume in meters cubed. And we're just following along with this example. What we've done so far really is just define 3 variables in MATLAB. So capital P, MATLAB will now know is equal to 100. Capital T, once we run this rather, MATLAB will know that that's equal to 300. And capital V, MATLAB will know that that's equal to 1,000. And let's go ahead and run this and see what happens. Remember, you can save it by just pushing save up here, or you can run it up here and it will ask you to save it if you haven't saved it already. We push the button up here to run it, and what it does is it puts the name of the file down here in the command window, and it runs our program. So what has it done for us? Nothing. Why not? It didn't put anything in the workspace. It didn't put anything in the command window. Why not? What was the first command I put in? Pause. So what is it waiting for? It's waiting for me to tell it to go, which means I need to click down in the command window, and I need to hit some key on the keyboard. Any key, doesn't matter. And once I hit any key on the keyboard, it will run the rest of the program. It clears the workspace, it cleared the command window, and then it put in P equals 100, T equals 300, and V equals 1,000. And those 3 variables show up here in our workspace so that you know that MATLAB thinks that capital P is a number equal to 100, capital T is a number equal to 300, and capital V is a number equal to 1,000. So you've just put in 3 variables into MATLAB. Okay. So that's our program so far. No big deal. You could also run this directly from the command window by putting in the name of the file, Jared Daily _ 012418. Was it 18 or? Yeah. And if you just type that in here into the command window and run it, it will run the file. Again, it's waiting for me to hit another key. I hit another key, it puts those in again. So it just ran the same thing right over again, which is why it doesn't look any different. But that is our very simple file so far. Of course, we could just type all this stuff directly into the command window and test it out. And that's generally what I do when I'm just trying to test something out, is I directly type it into the command window, and then when I figured out that something works, I put it up here into my document, into my M file. And I recommend that when you're working on your programs, try things out in the command window and then put them into your M file as soon as you figure out that they're working. Do not just leave things in your command window. It's so easy to lose what you put in your command window because that stuff is being stored temporarily in the RAM in the RAM memory. The stuff that's down here is stored in RAM. The stuff that you save up here gets stored on the hard drive. And RAM memory is easy to erase and easy to lose. So remember that. This stuff over here is in RAM memory, but if you save it as a command here, then you can run it anytime you want. So after we put in our V, the next thing is to put in the next variable, which is the molecular weight of air. Right? The molecular weight of the air is the 29. We go ahead and put that in. We suppress the output again so that it doesn't print to the screen. We don't ever want everything printing to the command window. We just want our answer or the final thing printing to the command window. And that, my comment is going to be molecular weight, right? And you could put the units in there if you want to. It's a good idea. I'm going to refrain from putting units in because I'm running out of time if I do all this all the time. In class, I have to take some shortcuts just because we're hurting for time. So here's our R constant, right? We throw that in there. I'm not going to comment on it. And then the final thing that we're going to put in is now a calculation. We want to calculate the number of moles, because this is going to help us to calculate. We have the molecular weight, and we want to eventually calculate the mass, but to calculate the mass, we need to multiply the number of moles times the molecular weight. That's what they told us in here. That's not anything we had to figure out. They told us how to do that. But we need to first calculate the number of moles, and then we can calculate the molecular weight. So the number of moles is equal to, that's the equation they solved for us at the top of page 26, it's equal to P times V, so you actually have to write it, P times V, and then it's divided by R times T. Okay? Now there's a problem with this. Can anybody guess what the problem with this math might be?
T is in the denominator.
The way that we've written this, we're going to multiply P times V and then divide by R and then multiply times T. But we want to actually divide by R and T, right? So whenever you're dividing things, it's a good idea to put parentheses around everything in your denominator. Some people like to put parentheses around everything in their numerator. That's not absolutely necessary. But it's a good idea to group things using parentheses. It's really important that you understand order of operations in mathematics as well. Remember that if you just have multiplication and division, a computer will just look at that by character by character and just do it one after the other, multiply and then divide, then multiply and then divide. But if you have parentheses in there, it will go and do that math first and then do everything else, right? Also, if you have addition and subtraction, it's going to do any multiplication first and then addition and subtraction. So it's just very important to be careful with these things. Like I said, many people will put in parentheses here. It's not absolutely necessary, but I am one of those people that will do it so that I know that this entire thing is divided by this entire thing, right? And I don't want to necessarily print that out to the screen either because it's not the answer I'm looking for. But I might want to write in here a little comment that says, this is the ideal gas law, right? Just so you remember, ideal gas law. And then we move on to our final answer. So now the final answer is the mass is equal to the molecular weight, which was already defined up here as 29, times the number of moles, which is defined, which we just calculated just right above this. And I'm going to go ahead and leave that without a semicolon so that it will print to the screen as the answer to this whole problem. And then I'm going to write down here and say this is the mass. I'm going to go ahead and press run and it'll ask me if I want to save it. Didn't, it just saved it for me. Usually it says, do you want to save it? But anyway, apparently it saved it automatically. I'm going to click down on my command window and I'm going to make that pause happen or make that pause go away by clicking the button. And it goes through and it calculates the mass at 1.1627 e to the 3, which is 1,162 kilograms at that point for the mass. So So there you go. You've got your solution. You want to check it, plug it back into the equations that you have and see if it checks out. See if it makes sense to have that kind of a mass going on. It is correct, in case you're wondering, but this is a very simple MATLAB program that solves a problem. But it doesn't seem like you would use a computer for a problem like this. This is something you could pretty easily do on paper or with just a calculator without even using paper. So why would we learn to do this? Well, here's the reason. What if instead of calculating the mass, let's say I want to calculate the mass not for just one pressure, but let's go up here and put in 100 for my pressure, but also 200 for my pressure, and also 300 for my pressure, and also 400, and 500, and 600. And let's do that all the way up to like 10,000. I keep entering in numbers like that. Make this into an array of numbers by putting square brackets around it. And then go ahead and run it and see what happens. Let's see. Did it go? I think it did. Yep. So I get on here and I press enter. And this is what I get. Now I've got m is equal to an array of masses instead of just one single mass. It's got 1 times 10 to the 3, so each one of these is multiplied by 10 to the 3. But there's 1.1627 for the first. There's 2.3254 for the next pressure, 3.4881 for the next pressure, 4.6508. MATLAB can do many calculations very quickly. Okay? So that's a useful feature. Now make sure that you're writing your file and taking your notes on this. Some people actually prefer to go back and watch the video and take their notes later. But make sure that you're doing that. You're writing down the things that we do in class in your file, in your M file, just like this, named with your name and your dates here. And you're saving that stuff. But also that you're taking notes on things that we do. So maybe you want to put this in and change this and make a note of that. You wouldn't want to change it in your file up here. You'd want to put a new change down here. So maybe in your participation file, you might come here and copy all this and come down here and say, paste, I'm going to change this to this thing and make a new part of your file. It's a very quick way to make a new version of that little program.
The answers on mine went vertically, they didn't go horizontally. Why is that? Or does it matter?
So it depends on how you enter in your array up here. I put commas in between it, so it defined it as something that had several columns in a single row. If I didn't put commas in, it would define it as something that has several rows and just one column, and it would change everything. So if you do that and then run it, and down here. Actually, it didn't do that. You have to put in semicolons. It depends on how you define your array. And it may even be a different version of MATLAB. Sometimes different versions of MATLAB have changed things. But let's try this one and see what it does. So now it puts it in as a column. Is that what you were talking about?
Yeah.
Yeah, it depends on how you define your array. And MATLAB will then go with however you define it. So right now it's giving me two answers, one in a row and one in a column, because I have two programs up here, one after the other. That will become very important later, because later on actually is the very next section. As we work with arrays, it's important that your array be exactly what you think it is. If you think it's a row, you need to make sure that it's a row, because that determines how you're going to treat it, how you're going to work with it, and how MATLAB perceives it, and how it does things to it. So it is important to recognize that arrays can be written either way, so that they're a column or a row, or many columns and many rows. But important to understand how that works. So, let's make some arrays. We already did some simple arrays last time, so let's do some more. Let's learn some array operations. I'm going to go ahead and come down here and clear the command window out. You can go ahead and continue making notes in your document, but I'm going to work directly from the command window for a little while, so I don't have to keep running my document. But let's say that we want to make an array of numbers that is a very simple array. Like let's call it A, and we want A to be equal to the array of numbers. Put in our square brackets for our array of numbers, and we want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so on and so forth. 15, right? So there we go. A simple array. We go ahead and push return, and it gives us a bunch of columns. So it's a row and 15 columns essentially, with one number in each column. And that's what it looks like. If we go over here and press and open the array A, this is what we get. So there's our columns. Here's the one row with all these columns. Very simple. However, there's a simpler way to do this. There's a faster way to do this. I'm going to go ahead and close out of my variable here. And I'm going to go down here and I'm going to say A, let's let A equal 1 semicolon 15. And I'm going to hit enter. And it gives me the same thing. And what that command says is it says I want to give me every number between 1 and 15 with steps of 1. And I put them into an array. It's this very simple command, and it's a very quick way to form an array. Is your computer not working there, Brandon? It is? Okay. So anyway, you've got this very simple way of creating this array. Now I can also do an array B equals, and I can go from 1 to 15, but let's say I don't want to make an array that goes by ones. What I do is in between the 1 and the 15, I put in the number that I do want to go by. Let's say I want to go by odd numbers. I go 1 steps of 2 to 15, and then I hit enter. So it gives me every odd number. It starts at 1, it ends at 15, but it goes by a step of 2. 1, 3, 5, 7, 9, 11, 13, 15. And you can pick any step size you want within the limits of the computer, which are pretty broad. Not likely you'll ever break those limits. Let's say that I would say D equals 1 by steps of 0.005 to 15. And I'm going to go ahead and suppress the output of this because it'll print a huge thing. So I'm going to hit return, and then I'm going to go over here and open up D and see what it gives me. So it gives me this huge array of numbers by steps of 0.005. Right? How many numbers are in this array? Well, we close out this variable, and it'll tell us that it's a 1 by 2,801 double. So it has 2,801 columns, one row, 2,801 columns, and it's a double array because it gives us a double. It uses two. When it says double, it's using 2 bytes to represent the numbers, so that it gives you a lot of space on the in the memory to hold each number, 2 bytes. If it's a single, then it gives you half as much precision on your number, so you can only have so many digits with a single. With a double, you can have a lot of digits, and it will still store the number. So normally, the default is to use a double byte array. Anyway, that is one very simple way to make an array. You can also there's also another command called the linspace command. Now I'm going to rewrite my D array that I just wrote and write D equals, this is at the bottom of page 28, by the way. D equals linspace. So this is a function. And whenever you have a function, instead of just a plain old command, you have to have these parentheses and then have some parameters that you enter into those parentheses. For linspace, you start off with the first number being the number that you want to start on, and then you put a comma, and the second number is how many numbers you want to be in the array, And then the last number is the last number that you want to be in the array. So what this is telling MATLAB to do is to create an array that starts at 1 and ends at 3 and has 10 linearly spaced or 10 equally spaced numbers total. So let's see what that looks like. Oops. I told you backwards. This one starts at 1 and ends at 10 and gives you 3 equally spaced numbers total. Sorry, I forgot which order those go in. But anyway, you have your first number at 1, your last number at 10, so those are the first two numbers. And then you wanted 3 equally spaced numbers total, so it starts at 1, ends at 10, and it gives a number that's exactly in between those two for the third one. But what if I switched that? Remember, if you use your up arrow on the command window, it takes you to your last command. And then if I switch that number to between 1 and 10, and I want to do 6 numbers between 1 and 10, and then I hit enter, it gives me 6 equally spaced numbers between 1 and 10. So it gives you linearly spaced numbers. This is extremely useful when you're doing all kinds of different things, especially when you're trying to plot something. Let's say that your lowest number on your plot, on your data, is at 40, and your highest number of your plot is at 40,000, and you have 10,000 points of data. Well, then you put a linear space thing between 40 and 40,000 that has 10,000 points, 10,000 linearly spaced numbers. Then that will give you an array of numbers that is the size of your data. Exactly. And it has index numbers between 1 and whatever. So it can be useful in many, many different ways. Just like the linspace command, there's another one called the log space command. So if I let e equal log space, and then put in some numbers. I start with my beginning number. In the book they use the number 1, but I want to use, yeah, let's do that. So they're using 1 and 3, and then they use 3. For log space, this does something quite different. Let's see what it does. It starts off with 10, ends at 1,000, and it gives us 3 total numbers. So the last number means the same. It's 3 total numbers. But what we're talking about here is not starting at 1 and ending at 3. We're starting at 10 to the 1, which is 10, and ending at 10 to the 3, which is 1,000. So this is a logarithmically spaced number set, where we equally space these things logarithmically. Now, this is not equally spaced linearly. This is not, 100 is not exactly between 10 and 1,000. But it is 10 to the 2, where this one is 10 to the 1, this one's 10 to the 3. So it gives you 10 to the 2 in between. And you can do all kinds of crazy things with that too, with the log space. With the log space, you can do, between 1 and 3, you can do 50 of these things. And of course, that's going to look very different. 50 logarithmically spaced numbers is going to start at 10, which is, this is 1 times 10 to the 3 times 0.01, which is 10. But it's going to give you all kinds of numbers in between, which again can be quite useful. We will not use that in this class very much, but it is used a lot in science and engineering and mathematics. Now, I'm going to go ahead and clear my window out again. CLC, clear the command window. And I'm even going to clear all my variables so that I can start fresh here, move on to the next parts. And I'm going to define some new variables. These new variables are going to be array variables, or arrays of variables. So I'm going to say that A is equal to 1, comma 2, comma 3. Put that in a square bracket. And put another comma in there too. And I'm going to actually get my brackets correct. Hit enter. So I've got my first array, A equals 1, 2, 3, and then I'm going to do a calculation. I'm going to say that B equals A plus 5. So let's see what happens when we do this. When you add a scalar number or a single number to an array of numbers, what it will do is it will add that number to every number in the array and then give you a new array, 6, 7, 8, instead of 1, 2, 3, right? It's true even if A is its transpose. You can, if A is a column vector, I can actually say, if I do A prime, for example, it gives me 1, 2, 3 as a column vector. A apostrophe switches your vector from, well, temporarily, from a row to a column, or a column to a row, switches them. So if I do 5 plus a prime, for example, let's see what it does for us, then it gives me 6, 7, 8 in the column. So it will do it either for columns or rows. So adding a number to a vector is not a problem. It does that. You just have to know what it does. It adds it to each member of that array, or each element of that array. Each part of an array, each individual number in an array is called a member or an element of that array. But now let's do this. Let's do A times 5 and see what happens. So A times 5 did the same thing and multiplied each element of the array times 5. And that's great. Sure. And let's say that we have A and B now. We do have a B up here. B is equal to 6, 7, 8. Let's say A, and let's see if we can add A plus B. Can we do that? A plus B? Sure. It took 1, 2, 3 and added it to 5, 6, or 6, 7, 8. Yeah, 6, 7, 8, right? So we got 7, 9, 11. Because A was 1, 2, 3, B was 6, 7, 8. It just added them term by term. So the first term of A got added to the first term of B. The first term of the second term of A got added to the second term of B, and so on. So it adds it. We call that element by element, or elemental, sometimes we call that, or term by term. So it just adds them together that way. And the same thing happens with subtraction. If I take B, or let's take A minus B, I'm going to do B minus A, but let's do A minus B. See what happens. A minus B, and it gives you negative 5, negative 5, negative 5, because 6 minus 1 is negative 5. Sorry, 1 minus 6 is negative 5, 2 minus 7 is negative 5, and then 3 minus 8 is negative 5. So it'll do it. It'll do adding, it'll do subtracting of arrays even. However, let's do A times B. Uh-oh, that's a problem. How many of you have ever done any kind of matrix mathematics in a class before, like an algebra class, where you multiply 2 matrices together? Nobody? Well, when you do that, it turns out that matrix multiplication is done a very specific way, and there are different ways that you can do it. So multiplying matrices or multiplying arrays, you have to tell MATLAB exactly what you want it to do, or it will not do it. Okay? So you're not allowed to just multiply them together because it needs very specific things. We are allowed to do some multiplication. We can do A dot times B, and when we put a dot in front of it, it means that we're forcing it to multiply it element by element. So the first element of A times the first element of B, the second element of A. So we're telling it that that's exactly what we want it to do, and then it will do it. It'll multiply A times B. And we can do the same thing with division. We can do A dot divide B, and A dot divide times B, and it knows how to do that. And the same thing with A raised to the power of B. So if you do A dot and put B in the exponent, it knows how to do that as well. But you have to put that dot in first to make it work element by element. Otherwise, it doesn't know to do that, and it says, sorry, there's an error, you haven't told me exactly what you want, because there are different types of multiplication when it comes to matrices. This is only one of them. So when you're multiplying arrays or matrices together, make sure that you tell MATLAB exactly what kind of multiplying, dividing, or power things you want to do. Okay. So the next thing are some examples using matrices and arrays. And then displaying numbers, saving work, formats, diary. So a lot of the stuff towards the end we've already done because we've learned how to use an M file or a script already. The next thing is, the last thing that they do is section mode, which I actually already did. So you see in my M file here where I created this area that has this yellow part, that's what's called a section. It puts a little line in here and then shades it a different color. And if I go down to the bottom and create a new section, let's see, there is a way to do it up here if I'm trying to remember how to do it. New, nope, that's not there. But there is a way to do a new section. I thought there was a new, yeah, right here, insert. So if I if I put this little button up here, this is for inserting a section. If I click that, it'll insert a new section. So I have this section up here, and now I have this section down here, and whatever section I'm in, it will highlight it yellow. And that's kind of useful for when you're trying to edit and doing a lot of editing of your own programming, or someone else is checking your work. So it's not a bad idea to put a new section every time you have a new problem in your M file or whatever, a new whatever. But it's not required, but it is good programming technique. So you'll get extra points for using the insert a section thing here. So that's a useful little thing they teach us at the end of this chapter. And now let's just kind of do some examples. Some of the last few examples here so that you can see how we're going to use arrays to do mathematics here in MATLAB, to do problems in MATLAB. Let's see. That's oh, I'm on the wrong page. I'm like, we already did this one. What's going on here? Okay, so let's go to the right place where we have our correct. There we go. That's the one I want. Matrix calculations with scalars. That's what I'm looking for. Okay, so first thing that we're going to do before we do that is to practice making some tables of numbers. So we'll go ahead and do that first. We're going to so we're going to make a table of numbers with degrees and radians, for example. So we say degrees equals, and we go ahead and enter in some numbers into an array. We're going to do 10, we'll do 15, do 70. This is page 31, by the way. We'll do 90. So there's our array. It's got a single row, 4 columns in it. Good to go. Now we want to define something called radians, where we'll calculate the number of radians from each of these degrees values. So radians is going to equal our array degrees times the conversion factor, which happens to be pi divided by 180. Remember that MATLAB understands the number pi as pi. So pi divided by 180, or 2 pi divided by 360, for those who are sticklers about that. And there we go. Radians is now equal to the equivalent in radians to those numbers of degrees. But then if we want to make a table of these things, we can actually do that in a very simple way. So we'll call it my underscore table, just like they do. And we'll let that equal. And we're going to make a new array using 2 other arrays. Can you guess which arrays we're going to use? We're going to use one of them as degrees, and one of them is radians. So we're going to just put those right into our new array. We're putting an array within an array. Perfectly legal in MATLAB. And let's see what happens. So we've got this weird thing. We've got the degrees, 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 and then radians, radians, radians. Let's open that up and see what happened. My table. It looks like it just put in one of the tables, and so it put in one row of degrees and then one row of radians right after it. This is what we call concatenation. So it just put in one right after the other because we had 2 row arrays and we made a new row array. It just made one long row. So, and that's not maybe what we want for a table. Maybe we want to have the degrees in a column and the radians in a column right next to their degrees, right, to compare. Usually that's what we want to do. So we want to go ahead and try to fix this and maybe do this a little differently. Now remember that when we wanted to make something into a column, we put an apostrophe after it. So we'll go ahead and make these both into columns. And now what it's going to do is going to put them one after the other, but now they're going to be columns. So that'll be good. And what happens? We get a table that has 10 degrees equals 1.1745 radians, 15 degrees equals 0.2618 radians, and so on and so forth. So that makes a little more sense. And you can even check the answer because 90 degrees is about 1/2 pi, or pi halves radians, right? So 1/2 pi is about 1.57. 1.57, double it, you get 3.14, right? Which would be pi. So that you can check your answer there and it works. It's very nice. So that's one way that you can make a table, making sure that you have columns of numbers put into your final array here.
When I go to my graph or my workspace and double click it, and it opens it in like the Excel sheet, it only has one row. It just does the degrees, or does the radians, it doesn't do the degrees.
So you didn't get the degrees in there? You have one column or one row?
Well, if my command window looks like yours, it says the 10 and 0.1745, but when I double click, oh, there's the problem. Never mind.
Did you find it?
Yep.
Good, you're getting some practice in debugging your code, right?
Yeah, I need that.
Good. Okay. So let's do another example here. Let's do this example 2.2 on page 33. We have a scientific data collected from wind tunnels, so we're in wind tunnels again. And it's usually in standard, in Systemic International units, which is, the metric system essentially. And we want to know much manufacturing in the United States is done in English, so pounds and inches and gallons and stupid things like that. And we want to be fluent in both systems. We're essentially going to make a conversion sheet. We want to convert some of these things back and forth. In particular, it looks like they want us to convert pound foots to Newton. I don't know why they want to use pound foots to newtons, because it's usually pounds to newtons. But we're making a table. Need to take off? Okay. Yes. Just as a reminder to everybody, these videos are online. So if you want to make your files, your notes online, and turn those into me online, you can get those through Blackboard, and then turn them in later. So yes. So anyway, we've got a conversion factor on page 33. And it tells us that 1 pound is equal to 4.4 newtons, and that is correct. And they want us to make a table that starts at 0. I'm not sure why you want it to start at 0, because everybody knows what 0 pounds is 0 newtons. But oh well. We want the final value in the table to be 1,000, and we want 100 foot-pound increments in between. Pound foot increments, pound. Anyway, 100 pound increments in between. So, and they tell us how to do this. We can figure out how to do this, though, I think. We've just done a table. I'm going to go ahead and clear my command window, and I'm going to clear my variables out of my workspace. And let's go ahead and just do this. Not a big deal. First, I'm going to enter in my conversion, and I'm going to enter in my table of values first, and then do my conversion and convert them all. So my table is going to go from 0 pounds to 1,000 pounds. So I'm going to make and they want it to be a 100 pound increment. So I'm going to use this particular, I'm going to use LB for my pounds. That's going to be my pounds values, my pounds array. And I put it in don't actually have to put it in an array thing. So this is going to be from 0, and it's going to go to 1,000 in steps of 100. So in steps of 100 to 1,000, like this. And I'm going to go ahead and just close that off.
You got 100.
Yes, I did. Thank you. 100 to 1,000. What did I do wrong? Oh, it's not commas. Don't put in commas, right? We put in, I don't know why I did that, but it's not commas, it is colons. So we put in colons. Colons, there we go. So now it's got what I want. To go ahead and over here and check my pounds. It's got 11 numbers from 0 to 1,000, steps by 100, right? That's great. That's exactly what I want. Close out that variable. Come back here, I know my pounds. Now I'm going to do my conversion factor. I'm going to write my thing for newtons using my conversion factor. So newtons is going to equal pounds times 1 pound is equal to 4.4 newtons. So I take my pounds, I multiply by 4.4, right? Times 4.4. And it's 4.448216 or something like that, whatever. And that'll make my newtons part of my table. And then I can go ahead and create my conversion table. I'll call it my SI underscore table, something like that. My SI table is going to be an array of numbers, and I'm going to start off with my pounds first. So I'm going to put in my LB, and I'm going to go ahead and put that into a column. And then I'm going to put in my newtons, and I'm going to put that into a column, hit enter, and there's my conversion table. Pretty straightforward. The only thing that you got to be aware of is that this is putting this in scientific notation, right? So everything in here is multiplied by 10 to the 3. 1e times 1e plus O3 means 10 times 10 to the 3. So this is 10 to the 3 times 0.1, 10 to the 3 times 0.2, and so on and so forth. So important to remember that. Okay. So, example 2.3 is not much different. It's calculating drag forces, drag coefficients in different situations, but you're just making a table of numbers and numbers again. I'm going to take a little bit of a break. Before we move on, there's just a couple more things in chapter 1, and then we'll be done with chapter 1, or sorry, chapter 2. But I am going to take a break for about 5 minutes, maybe 10 minutes, and I'll see you back here in a little bit.
No, mine gives me an error. Okay, so.
Did you say unexpected math lab expression?
Yeah, with the N.
That's because you gotta space out the LB.
You
So
do?
you're gonna do pound with the apostrophe in the space.
Oh, hey, my grandpa.
I got a picture, but mine won't have any numbers.
Mine doesn't have any numbers, that's the problem. Oh, did you run this program?
Right, I said run.
It's really neat. Yeah, I'm doing it in command. I'm doing all this stuff.
The one piece out of the pound.
I think on the one up top, you get 1,000.
But you could survive. Really? So you could survive without the book, but about MATLAB before that.
Yeah.
But you can't even make it. This one, $5. Under $100 something.
Because I need for my engineering. What is your degree?
I made it in.
Yeah.
Yeah, okay. Honestly,
Yeah, same thing happened. First start. Like people talking about this, so actually.
important,
I know.
but then
Chinese
there's like three, you really need to know.
Which is what we talked about.
In the middle of all these things.
I know.
I
Yeah.
I looked at the first one,
The
like,
capture thing.
Basically, due dates.
It's only page 814 or
Yeah.
8. Yeah, that's what I'm saying. Same one. Yeah.
Excited. Are you emailing all of these sources?
Oh, I can. I made a mistake.
Yeah, I did too.
I emailed myself all the sources and then I copy and pasted the entire article.
All right. We ready to go? Finish up. Okay, the last thing that I want, the last things that we're going to do here is we're going to talk about different ways of formatting things in MATLAB. So number formatting, different ways that MATLAB keeps track of numbers, I guess is a way of saying that. And also we're going to talk about loading things into MATLAB, because MATLAB can bring in things from external sources. So, and I think that's it. I think everything else we've already covered because we've already done. Yeah, because we've already done M files, so we're pretty much good. So anyway, of course, I just mentioned that this is in scientific notation because it's some number times 10 to the whatever, and that is the default number formatting in MATLAB. When you turn on MATLAB, that's what you'll see. However, you can change that, and the way that you change that is by giving MATLAB a format command. So you say format, for example, and go to format long. That's one of the different formats that you can do for MATLAB. If you do that, and then we go ahead and we look at SI table, then it gives us a much longer set of numbers. It essentially stretches out each number to its maximum precision. So it's still in scientific notation, but it gives you all the digits that are available. But then you can change to format short and bring that up again. And it goes back to what it was. So the standard in MATLAB, or the default, is short format. So those are two of the formats, but there are also others. Let's see. Yeah, that's what it is. And remember what it is. So if I go to format short, and then I put an E after it, this is what it does for us. It puts each number as a individual scientific number instead of putting that 1 times e to the something at the beginning. Each one of them is its own individual scientific notation number. And you can do the same thing with long, I believe. Let me just check really quick here. Format long E and go to the table. And it will put it all as individual scientific notation numbers. And then you can also do engineering notation. So you can do format, and this is more like what we're used to seeing when we do mathematics. Well, maybe not. No, it's not. What did I do? I did short engineering. Okay. So anyway, this engineering format gives you each as an individual scientific notation, but it gives you 3 numbers on the scientific notation every time here. So it's 0.003 or 000 or whatever. But it gives you 3 digits of actual number as well. So this one is 100 e to the 0, or 10 times 10 to the 0, so it's just 100. And once you get out of the 100 range to the 1,000 range, then it starts using scientific notation. So it gives anything less than 1,000 gives it to you in normal numbers. Then there's format rational number. This gives you everything in terms of fractions instead of decimals. So nice, whole numbers here, but fractional numbers over here, which could be a little bit confusing. But you can do there's just all kinds of different ways that you can format things. I'm only showing you the ones they're showing in the book. You can actually format something so it just shows you whether something is a positive or negative. Do format positive, format plus, and then do this thing. So it'll just show you whether things are positive or negative. First row, first column, positive. Second row, first row, second column, positive. Everything's positive on the thing. So there's just lots of different ways that you can format things, and if you want to know more about different formats and figure out one that you want to use, you can always use the help function. Help format. And this one will give you all kinds of information about different formats you can use. Doesn't give you everything, but if you want to know everything, go here to the doc format, and it'll open it up in a help browser, and it'll give you everything. So just lots and lots of different formats that can be used to display numbers. They give a whole bunch of them on page 42 as well, at the top of page 42. There is a diary function in MATLAB where you can keep a diary. I've never used it. It's kind of a new thing that it wasn't in MATLAB when I started using it, so I've never used it. But it's kind of like having a file where you can keep notes and it keeps track of what you're doing in MATLAB as well. And you're more than welcome to use it if you'd like. You still have to name those files like you'd name all MATLAB files. But let's take a look at it. I've never done it. Diary, go to diary on, hit return, activate the diary function, so put diary on. So now it's recording. So essentially it's going to record everything I do, I guess. Recording now. And then when I get done, subsequent store diary session in different file. So you get done, I just put diary off, I guess. Oh, it wants some actual functions. So let's put in x equals 1 to 1,000 or something. It's fine. And then I put diary off. That recording now was, I meant to put I meant to put some comment things in there so that it would just record my comment, but I forgot to. So I'm putting diary off here, and what it's going to do is it's going to save it automatically in a file called matlab.mat. No, it's going to save it in my. No, I don't know what it's going to save it as, but I'm going to save it now. So I'm going to say to save it, I put diary, and then I put the file name, and I'm going to put diary. I'll put my diary, just like they do, my underscore diary. That's fine. Hit return, and then I should be able to run that. Now, I should be able to open it up by just putting my underscore diary. Let's see if it does. No, can't bring it up that way.
It's like load or not?
I don't know if it's going to make us do load. We could maybe do load my underscore diary. Let's try that. It didn't do anything.
They have brackets around my diary,
You mean, let's see.
for the greater than less than.
No. Oh, I remember. Has to have quotes around it. You have to load, when you're loading a file, you have to put quotes around the name of the file. But it still doesn't seem to be telling me anything about my diary. Well,
Use the greater than less than quote for bracket.
no, those are just to, and that's kind of confusing in the book when they use those greater than less than brackets. That's just saying that that's what you're going to put in there. It's not necessarily, it's a user-defined name, so you're going to choose what your file name is there. And they say that at the top of 43, but it's not necessarily very clear. So ignore anytime there's those greater than less than brackets around something. That just means that's something that you enter, you choose to put in however you want to put it in. Okay, so yeah, I'm not sure how to use the diary, and I'm not really all that hyper about it anyway, so don't worry about it. Everything else in here, we have not done a load, but to load, you do what I just did before, not this last time, but this one right here. To load a file, you put in the command load and then the name of the file. And so if I want to load in the file Jared Daly, you put that in, but you put it in that way. But most of the time, when we're loading things in, we're loading in data files, files that are full of numbers, or full of something, some kind of data information, so that we can use that data and information, and we will get plenty of opportunities to do that. But be aware that you can do that in MATLAB, load in different files with different information so that you can go and take data using some kind of scientific instrument or a camera even, or whatever else, because all digital data is just arrays of numbers. That's all it is. When a camera takes a picture, that data, that JPEG file, is just arrays of numbers. And what those numbers tell you is they tell you, first of all, they tell you where each pixel is located, and then it tells you what color that pixel is, and then it tells you what brightness that pixel is, and then it goes on to the next pixel. So each cell in that array has essentially 3 of its own little cells, or 3 of its own, an array of 3 other numbers. So that's just arrays within arrays, and that's all digital data is. It's just arrays of numbers, which are very easy to store. They don't take much space. That's why cell phones now use digital data, because if you can talk on a phone and then turn that into just some numbers, that's way easier than sending a waveform. Old phones used waveforms that took so much data, took so much bandwidth to send. Sending a wave takes a lot of radio waves, essentially. But sending just numbers, very easy to do. You can send tons of them very quickly. So it's very nice. The only problem is converting voice to data takes time. So that's why you get that little delay, and they're getting better at that. And that's why your phone has to be a computer, because it has to convert your voice waves into data arrays. But I mean, MATLAB does really well with arrays. So if you have digital data somewhere in an array, then it's a beautiful thing for MATLAB. MATLAB loves that. And finally, we are done with this chapter. Now, many of you already turned in homework or submitted homework. That doesn't mean that you can't go back and change it, because I am going to give an extra week on this homework or at least a few extra days on this homework since we didn't finish chapter 2. And we will start, we can take some time to start a bit of chapter 3 here as well. Trying to decide how much of chapter 3 we can get through and the time we have left. We have about an hour left, a little bit less. I'm thinking that we can probably get through at least the first few sections here. So we'll go through and start chapter 3. But before we do that, I will ask if anyone has any particular questions about the homework, specific questions that I can answer before we move on.
A couple of us here in McCook anyways tried to do the homework this week.
Yep.
And we are realizing now that we definitely did it wrong.
Yep.
So is it all right if we just go ahead and resubmit or change what we submitted?
Yeah, absolutely. You can go in and you can replace the files that you submitted, and that's perfectly fine. Remember to name your files correctly, so your name _ week 1 p2, so w1p2.m, and then within each question, I don't know what you're seeing here, but let's go to my desktop. So within each question, you have each problem. Make sure that you put a pause in between each problem. You might want to make each problem its own section, and so on and so forth. But put a pause in between for sure, so that it makes it easy for me to run a little bit of your program at a time and check it a little bit at a time. With these beginning programs, it's not very difficult. We don't do anything really challenging here, but still it's useful and helpful for us. Any other questions? Hopefully you didn't find this anything too challenging. It's not really all that challenging. The most challenging thing is just getting it put together properly so that it runs properly. But I would recommend that when you're done writing your M file that you run it and see how it works. See what I'm going to see. Because I'm just going to open up that file and I'm going to run it, and then I'm going to look at your code. And I'm going to look at your code, and then I'm going to run it, and then I'm going to look at your code. And I'm going to grade things according to the rubric here, the grading rubric. So if we go up here and view the rubric, there we go. I'm going to look at it, and I'm going to look at it for completion. And if you have completed everything, you've done every single bit of problem in there that it asks you to do, then you'll be getting a score upwards of 35 points. But if it's barely complete, you're going to be looking at much lower points. So that's a total of 35 points out of 70 for this problem. Program functionality will be between 0 and 21 points. So if nothing works, then you'll get a 0. But if everything works, you'll get a 21. And then style and cleanliness, I'll be looking at things like comments. Did they use sections? Did they use pauses? Did they use spacing effectively? Make sure that you realize that there can be too much of these things too. You can have too many comments. If I can't read the code because there's 5 lines of comments in between each line of code, that's a little overdoing it, right? You want to be judiciary in using your judicious is a better word, in using your comment lines and everything else. So make sure that it just makes sense what you're doing. But that's where your style and cleanliness will come in. It's all those kinds of things, the kind of the programming practices, I guess, best programming practices. And I will give you scores accordingly. And then I will usually enter in some comments as well that you can read so that you can know what to do better, know what you did wrong. For the most part, I'm pretty harsh on the first assignment because the programming is so easy. It's not hard to do anything. So I spend a lot of time making sure that you are making sure that you're doing things with good style and cleanliness. So don't just slap something together for this first week. Try to use the programming practices that I've shown you and make it look as clean as possible. Any other questions?
So for like problem number 1, you want to pause between each one of those, the 1 and 3 quarters.
Yeah,
and 5.
so in each question there may be multiple problems. And if there are multiple problems in a single question, then go ahead and put a pause between each question, or a pause between each problem. So problem 1, put a pause after you've done all this, and then problem 2, put a pause after you've done all this, just so I don't see all this stuff thrown into the window at once. Because then it's hard for me to see what happened with each individual thing.
I didn't know if you wanted to pause after the 1 plus 3 quarters.
Yeah, probably not a pause after each one of these, although you could put a pause. You could actually put a 1 second pause after each one if you wanted to. So you put a pause and then parentheses 1, and it will pause it for 1 second and it'll move on to the next thing. That way it'll just print up on the window 1 second apart. That might be nice. And that would earn you points for style, for programming style. But I wouldn't put a pause that makes me have to press a button between each one. That just doesn't make any sense. But after each problem it makes more sense. But there are certainly programming assignments that I will give you where it will make sense to have a pause in between different parts of a single problem, because there will be much longer programming problems that we will do later. So using the pause will be something that you'll have to learn how to use according to what you're doing. And there are other alternatives to the pause command as well that we will learn about later. You may learn about them on your own, in fact. Okay, if there are no more questions or concerns, are there any more questions or concerns? If there are none, then we will go ahead and move on and do a little bit of chapter 3 for the next 40 minutes or so, 45 minutes. So, chapter 3 is entitled Built-in MATLAB Functions. And MATLAB has a lot of built-in functions, and it has a lot of built-in functionality that you can add to it if you pay a little bit more for it, different things. And not only that, but you can add built-in functions. You can actually make functions that you can build into MATLAB. So let's take a look at some of these things. Let's go ahead and start with clearing out our stuff here that we had before. And let's look at this. Let's define x equals 9. Go ahead and suppress the output. And let's use the square root function. You've probably seen this one in different things, maybe there are different places where you might see this function. But the square root function, what did I just, oh, I'm in the wrong format. You need to go to format. I actually like format short. Engineering is my favorite, probably. And then let's do our square root of x again. So the format, let's actually just do format short. That's a little easier to read for most people. So square root of x, which the x was 9, of course, gives you 3. Notice that it does not give you both answers for the square root. What's the other answer for the square root of 9? Negative 3, right? It could be negative 3. Doesn't give you that. MATLAB doesn't like messing with that, so it gives you 1 square root answer. There is a way to change that as well. I can't remember what format that is, but there is a way. There's a format that will give you that, both those answers. But the default is that it gives you an answer as a positive number if you take the square root of a positive number. Now let's take x equals negative 9. Let's do the square root of x now. Notice that it does understand what imaginary numbers are, or at least it does understand how to do imaginary or complex mathematics. What it's given here is it's given you a complex number where the first number is the real portion of the complex number, and the second part, which is the imaginary portion of the complex number. So I, it does know what I is, right? I is a complex, is the imaginary part of the complex number, square root of -1. Let's see, what else do we have here? Oh, you can do the same thing with an array. So if x doesn't equal just a single number, but equals an array of numbers, like 1, 3, 4, 5, 8, 25, 34, whatever. The square root can handle that. Take the square root of x. It knows how to do it. Does it term by term. Take the square root of each term individually and return an array of the square roots. All right? There's also a function called the remainder function. Can you guess what this will do? Remainder of 10, 3. What does it do? It takes 10, divides by 3, and tells you the remainder, right? So that can be useful. That can be extremely useful. There is a function called the size function. So if I ask for the size of x, it will actually tell me that the x has 1 row and 7 columns. 1, 7, right? So it tells me the size of this x array that I put up here. 1, 2, 3, 4, 5, 6, 7 columns, 1 row. Good to go. Of course, if you have an array y that has several rows and several columns, equals this, like 1, 2, 3, and 3, 2, 3, 1, and 4, 5, 6, or something like this, right? And you ask for the size of y, then it tells you it's 3 by 3, 3 rows, 3 columns. Right? Believe it or not, you can even have matrices that are more than 3 by 3. You could have 3 by 3 by 3, where each element of this array has elements within it. Something we won't deal with for quite a while in class, but it can be done. You can have more than 2-dimensional arrays. You can have 3-dimensional and beyond. To MATLAB, it's just places where you're storing numbers, so it doesn't care about dimensions. But you can also send these two numbers to some variables. So what I'm going to do is I'm going to make an array of variables. The first variable I'm going to call rows. The second variable I'm going to call columns. So I've made an array of variables, and I'm going to assign those variables inside that array to 2 different numbers that I'm going to get from the command function size. So the command function, or the command size, or the function size, returns 2 numbers, and I'm going to put those 2 numbers into this array of variables that I've defined. So what happens is it says that rows is equal to the first thing that size returns, which was the 3, and columns equals the second thing that size returns, which was also a 3. So now it says rows equals 3 and column equals 3. This method of assigning more than one variable at a time is very useful, especially when you have a function that returns more than one variable at a time. And it's very quick. And we will use it a lot in this class. So make sure that you understand what I just did. I made an array of variables equal to numbers that were returned by a function. The first number returned by size I put into the first variable. The second number returned by size I put into the second variable. And you can do functions within functions. So I'm going to let g equal the square root of the sine of x. But I have to close out all my parentheses. If I don't close them out, MATLAB returns an error and it corrects it for you if it can. So it says, did you mean this? Yeah, that's what I meant. And then it's going to give me an array of numbers, which is the square root of the sign of everything that was in the X array. So if I go in here and look at G, I got the sign of the square root of everything that was in A, or X rather, whatever it was. So there's 7 columns, 1 row, so on. Okay, so we've already used the help feature, which is the next part in this chapter. I like to introduce that in the first chapter. On page 68, there is a table of common mathematical functions. Of course, it doesn't include everything, but it includes some. We do have sine, we have cosine, we have tangent, so sine, cos, and tan, right? And we have square root, which you already saw, but we also have things like the absolute value. So if you take the ABS, absolute value of negative 99, for example, then it'll tell you that that answer is 99. And then you can take the square root of the absolute value of negative 99, and it knows how to do that. Because it'll take, oops, I didn't get everything correct, did I? Yep, I didn't get square root put in there correctly. So it fixed it for me. So it knows how to do that, where it takes the absolute value, and it works inside out, so it works on the innermost function gets done first, and then it works outward by parentheses. It can also do, instead of square root, it can do the nth root. The nth root is nth root, nth root. So you can do the nth root of, let's say, 125, and take the cubed root of it. So 125 comma 3, nth root is 5. 5 times 5 times 5 is 125. So it can do the cube root things. There's also a function called the sine, which gives you the sine of a number. So if you want to know the sine of x, for example, remember that x is an array of 7 numbers. It'll tell you whether the x is a positive number or a negative number. So if it gives you a 1, let's see, so it gives you, if it gives you a 1, then it's a positive number. If it gives you 0, it's 0. And if it gives you a negative 1, it will be less than 0. So that tells you the signs of different numbers. And why would you want to know that if it's right on your screen? Well, oftentimes your numbers are over here, not on your screen. You don't know them; they're just stored over here somewhere, and you sometimes don't remember what these numbers are. So you need to know that. You can find that out, and then you can use that in computations if you need to. There's the remainder. There's an exponent, so e to the x, where that e is the natural number. There's a logarithm, which is the natural logarithm of x, and there's also the log base 10. And there's so many others, literally thousands upon thousands of functions in MATLAB. Those are just some of the common ones. They do some stuff in here with logarithms, which I'm not going to do because it is, we don't necessarily expect you to understand logarithms in great detail. I'm not going to use them and just confuse people. Although there is a really cool thing that you can do with logarithms with MATLAB, and that is you can create a program that will calculate how long you need to save money if you put a certain amount of money down and you put a certain amount of money in every month. And we'll do this later in the class, I think. And with certain percentage rates and how long you need to save to make $1 million, for example. You can actually build a function that does that, build a program that does that, where you just plug in the interest rate, how much money you're going to put down, how much money you're going to save every month, and it'll tell you how long it'll take you to make $1 million. So, who wants to be a millionaire? Of course, we all want to be millionaires. Okay, on page 72 and 73, they have a bunch of other functions. They have a rounding function. They have a round function, the round where you put the number inside the parentheses after round. Tells you to round, it just rounds to the nearest integer. So if it's 5.5, it'll round to 6. If it's 3.3, it'll round to 3. If it's negative 7.125, it'll round to the nearest integer, which is negative 7. So at negative 7, it actually rounds up to negative 7 instead of down. But anyway. And then you can also use the round to a specific decimal unit. So you can round a number and you put in your number and then comma. Let me show you how that works. So here's what round looks like. Just round, 9.4. But I can also use round 9.4, comma, and I want to round it to the nearest decimal thing. So I use, let's see. So if I round it to 3, or round it to 1 decimal digit, then it rounds it to the 9.4. If I do that and I round it to, let's see, if I let around 9.4127, but now I round it to 3 decimal digits, then it rounds to that third decimal digit, 9.413. So that's one of the round. There's another one though. There's one that's called the floor, which automatically rounds it toward negative infinity, towards the integer at negative infinity. So if you round 9.7, it'll round it down to 9. If you round negative 9.7, it'll round it down to negative 10, because it rounds towards negative infinity. So it always rounds towards negative infinity. And then ceiling, which is CEIL, so that's the ceil function, it'll round all numbers up towards positive infinity. So those are very specific types of rounding. Then there's one that's called fix, and it rounds a number to the nearest integer towards 0. So it rounds either down towards 0 or up towards 0, depending on if you're positive or negative. So a bunch of different rounding functions. And then there are discrete mathematic functions. You can do the factors of a number. That's just kind of fun. So, and it's also useful. So if you factor, this will give you the prime factors of a number. So factor, see if a number 859 is see if that's a prime number. I picked a prime number first time. That's not bad for a number of greater than 100. I know pretty much every prime number between 0 and like 200, but I don't know any above that. So to pick one above that is pretty impressive. But if we factor 857, I'll bet you that won't be prime. Well, maybe it is. It is. 855. Well, let's try 853. Goodness gracious. I just picked a range of numbers that's definitely... So there's the prime factor. There are the prime factors of 855. 3 times 3 times 5 times 19 is 855. But now we all know 3 prime numbers over 200. 853, 857, 859. They're all prime. And then there's also the greatest common denominator, GCD, right? So if you want to find the greatest common denominator between two numbers, you put it in GCD and put in the two numbers, whatever they are. Say 56 and 67, maybe. Not likely, because 67 is prime. So 1 is the greatest common denominator because there's nothing that they share in common in their factors. Oh well. But there's also a least common multiple, so you could do the same thing and do the least common multiple, LCM. It'll tell you the least common multiple between the two. That's the lowest number that they both can multiply to become, right? So 3,752, it's probably just those two numbers multiplied together. And then there's the rats function. Sounds kind of funny, but it is what it is. What this does is it represents a number as a fraction. So it turns your number into a rational number, whatever it is. So if you have 5.23654 or whatever, it'll turn it into the lowest. It'll turn it into the simplest form of a rational number for that decimal number. Then there's the factorial, right? Don't remember what a factorial is. It's a number multiplied by 1 minus the original number, multiplied by 1 minus that, and by 1 minus that. So for the factorial of 10, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times. So factorial, you spell it all the way out. Factorial, what is the factorial of 10? 10 factorial, turns out it's a big number. 3,628,800. And then there's if you've ever done counting theory, what do they call that? Can't remember, but it's gaming theory or counting theory. This also will do what do they call it? They call it permutations and combinations for you. So for combinations, it's ENGR1020. number of things that you can choose. In other words, ENGR1020, like that. ENGR1020. So it's the number of possible combinations that you can choose from a group of k number of items. And so you put in so inside your parentheses here, you're going to put in the total number of items, 10. So if you have 10 total books, and you want to know how many different ways you can choose 3 books from that group of 10 books. So it's like if you have 10 cards and you want to know how many different ways you can choose 3 cards, then you hit that and it gives you 100 different ways. If you want to do it, for a stack of cards, you want to know how many different 5-card hands there are on a stack of 52 cards, something like 2 million or something like that. 5 really. Then you put 52 comma 5, maybe, there you go, 52 comma 5, and it's 2,598,960 different 5-card hands in a deck of cards, right? So what does that mean the possibility of getting a straight flush is, or the royal flush even? So how many different royal flushes are there in that? There's 4 different royal flushes in a 52-card deck, right? 1 for each suit. So you get a chance of 4 out of 2,598,960 of getting a royal flush. What is the chance that even if you play poker for a living that you'll ever even see one? Not much. Most professional poker players, unless they're playing a lot of draw, and I mean this is for 5-card stud. But I mean, most poker players, if you're playing 5-card stud, you'll never see it in your lifetime. You have to play several 100,000 hands of poker before you ever see one, in likelihood. But it's just kind of crazy. But in a movie, of course, you see it every movie. Every movie where somebody wins at poker, they win with a royal flush. It's just nuts. I've certainly never seen one. Okay, so anyway, those are some of the, you can also get the primes, find all the primes less than a certain number x. You can check to see if a number is prime. There's an is prime function. There are all kinds of functions. And there are just so many different creative ways to make use of them. Of course, we mentioned that we have the trigonometric functions, and they have a list of those on page 76. You can convert degrees to radians using a function called dig2rad. Dig2rad. Put in your number in degrees, and it'll convert it to radians. They have another one, rad2deg, which converts it from radians to degrees. They have the sine, the cosine, the tangent, the asine, the hyperbolic sine, the hyperbolic asine. They have the sine in degrees. They have the cosine in degrees, the tangent in degrees. So sine d, tan d, cosine d, cos d. Anyway, there's just lots of different functions that are just built into MATLAB, and you can use them in so many different ways. So then the last thing that I want to talk about today and show you today are, let's see, what time is it? 1:59. Do we have time to get through all this? I'm gonna start on this section 3.5 next time, just because it's going to introduce some new things that I don't want you to forget for next time. So I'm just going to start on it next time, and then we'll have a couple of hours to really get it into our heads and make full use of them. So we'll finish up chapter 3 next time. Make sure that you get your chapter 2 homework worked on and done. And if you have any questions, please email me. You can go ahead and email me your M file even, and I can look at your code and give you pointers that way, so that's helpful. I can look at your code and I'll put in some little comment marks here and there maybe. But make sure that you do that earlier rather than later in the week, because later in the week things get busier with more and more people sending things in, so it's harder for me to get them back to you in a quick fashion.
Do you want us to email them to you? Or do you want us to submit them to the Blackboard thing?
Submit your homework to Blackboard for sure. Whenever you're ready, when your homework is done, submit them to Blackboard. But if you have questions on your homework during the week, you are more than welcome to email me your M file and say, I have a question about this number. Can you look at my code or whatever? So that's one quick way for me to see what's going on when you ask questions by email. Any other questions or comments or concerns? Okay, remember that the shared document is up and running and ready to go, so that you can enter in something that you've learned about MATLAB this week to share with everybody. But make sure to look what anybody else has entered, so that you don't enter something that's already been entered. Have a good week. We'll see you later. What's that?